Alright, hello everybody, and welcome to another review video. It's been a while since I've done one of these, and today we're going to review the PX-978 Digital Adjustable Temperature Electric Thermostat Soldering Iron Welding Rework. Okay, it's a soldering iron. It's available on Banggood, and I'll just bring in this tablet here real quick, and we'll have a quick look at the site. So it's a pretty good price, $20.83 to $22.14 Canadian, because I'm in Canada here. And one of its first really nice features here is that, how's that showing on the screen? Yeah, that's showing fairly well. Okay. You can get a 110 volt US plug, which is right here, and it's grounded plug too. That's another big bonus to its quality, provided that the tip of the soldering iron is grounded. And we'll test that in just a moment here. You can get a 220 volt EU plug or a 230 volt Australian plug. So nice selection on various different plugs because they actually put the flex on. They don't, although it says in the description that they'll send you an adapter, it looks like they actually put a flex on that matches your country. So that's nice. No death adapters, as Big Clive would say. Anyway, so I will include a link to this in the description below. I just wanted to show you the price there. Anyway, let's have a look at the soldering iron itself. First impressions are fairly decent. It's reasonably compact. It's got a nice little silicone rubber grippy bit here. It's got the Hako style tip set up here, so you've got the little nut with the frame there, and the soldering tip fits over top of the ceramic core. And the ceramic core goes a goodly way up into the tip there, so it delivers heat very close to the tip of the iron. Now, this is not the default tip that came with it. I should have left the default tip on it. Let me grab that default tip here real quick. Okay, so this is the default tip, which on cursory examination just looks like a standard default conical tip, but it's actually kind of weird. It's flattened off at the tip, which I've never seen before, so I may play around with this in a follow-up video, but we're just going to do a initial impressions review here. And I'm going to actually use the soldering iron with this tip. Actually, no, I'll use the weird tip. Yeah, I should do that. Anyway, so let's get on to the flex, which I was talking about earlier. Now, the flex is printed. This isn't going to show up on camera, but it has the qualifications of the flex is printed on it. It's a Tri-Ace H05VVH2-F, which I actually Googled. I have it up on the screen here. It's an industrial cable that's rated for use with refrigerators, washing machines, spin dryers, etc. So that's a nice high-rated cable. Now it says on the website for this particular brand of cable that it's a PVC sheath, which surprises me because this is actually very flexible. I was thinking maybe it was silicone, but it's a very nice, soft, flexible PVC, which is going to make soldering with it nice because I'm not going to have to fight with a stiff cable flex. All right, so let's grab the multimeter here and do a quick continuity test from the tip of the soldering iron to ground. So we'll just throw the tip back on here. And we'll do this. See if it's ESD safe. All right, so we'll take the soldering iron, this is not a soldering iron, this is a multimeter. We'll set the multimeter to continuity. We'll put the one probe on the tip of the soldering iron, which needs to hold still. There we go. and one tip on the ground pin. And we've got continuity at, that's dropping very rapidly, but 3 to 4 ohms, so very nice continuity to ground there. All right, let's open it up and have a look at the inside. So we'll go ahead and take this off. We'll fold this back. All of these soldering irons fit together about the same way. We'll go ahead and unscrew this. There we go. And we'll go ahead and push the circuit board out. There we go. So we've got a nice strain relief here on the flex to hold it into the board there. There's no electrical continuity. The closest trace we have is all the way up here, so there's no risk of getting shocked off of the strain relief there. We've got the control buttons for power here and the temperature up and down here, some shrouded LEDs with some current limiting resistors probably for those LEDs. I don't want to pull this foam up to check the traces, but that makes sense for those. A bunch of control circuitry here, various different support components. That's probably a temperature calibration screw there. Then we've got all of the control circuits on the back, noting that the colors here are done in the European style. And none of these chips have their text on them, so I can't even tell you what those chips are. But I imagine this is the microprocessor for the controlling the tip. This is probably, oh no, that actually has some text on it. What is that? That's an HC1405. That's a logic chip of some sort. HC1405. Let's see what that is. Maybe that's not an HC1405. HDM star HC14D5 maybe. Let's see if D5 reveals anything. Oh, a brief search for that text doesn't reveal anything, but let's have a quick look at the traces here. It looks like that's mainly just driving the LEDs and probably interpreting some of the button inputs here. It's interesting, I don't see a rectifier or a power supply for these chips. I'd have to more thoroughly reverse engineer, but I'm sure they've got a power supply set up here somewhere for them. Maybe just a capacitive dropper and it runs on AC. Interesting. Anyway, it looks like we've got this is probably a MOSFET using pulse width modulation for the temperature of the iron. It doesn't look like it actually has a temperature lead. Yeah. So, I'm assuming this this pin is going to be ground because that spring is going to be continuous. Yeah, that's the ground pin. Alrighty. This, I believe, should be neutral. Yes, which means that this is live. Okay. So MOSFET is switching on the neutral side of things. And it looks like there's fairly decent isolation. There shouldn't be any current leakage into the tip of the soldering iron, which is fairly common. Quite often you'll see about 90 volts AC on the tip of a soldering iron that plugs directly into the wall. And that's just capacitive coupling onto the tip. But being as we have the tip being grounded there, that shouldn't be an issue. But we'll test that in a few moments. All right, I did not plan ahead and get a power cord over here. Give me just a second here. I'll put this back together. How are we doing on time? 8 minutes. All right. All right, let's go ahead and plug it in. Pardon me a second while I reach way over here. I'm gonna have to stand up. All right, plug that in. All right. I'm definitely going to need an extension cord for this because this is not a very long, well, it's plenty long for normal people that have an outlet nearby, but I don't have an outlet nearby. So this is going to be a little challenging to test. I'll have to use it left-handed, which is going to be interesting. All right, so let's turn it on. That's not very comforting. That's probably my fault, though. I bet I didn't get the circuit board properly aligned when I screwed it back in. So, what did I do wrong here? Oh, hey, haha. Chris, you idiot. Whoops. What was that? Oh, I just lost a button. I'm going to go ahead and pause, and we'll be back. All right, so we're back after that slightly embarrassing little mistake there. I did put the circuit board for the soldering iron in backwards. So let's go ahead and plug this guy in. I went ahead and got myself a extension cord, so we'll be able to plug it in right here, and we'll do the first test right away, which is to see if there's any AC leakage on the iron. So we'll put that aside. That's going to come up later. Do that. All right, so we're going to set this to AC voltage, and with the iron off, we'll test from the tip of the iron to neutral, which is the big blade. And we've got nothing. All right. Let's make sure I was making electrical contact in there. Yeah. 168 millivolts AC, so there's no negligible leakage there. Now, when testing for AC leakage on a soldering iron, always test from the tip to neutral. Never test from the tip to ground or you'll trip your breakers. Anyway, let's turn it on. Looks like it's set itself to 380 degrees Celsius. Let's set it to 330 because that's actually closer to what I normally use. Now that it's on, let's see if we have any leakage. Nope, still a couple of 100 millivolts. So there's no AC leakage to the tip of this iron. That's a good result, as Big Clive would say. Alright, now this should be up to temperature by now. Let's clean the tip off. Yeah, that is a very strange tip. It's conical, but it's got a flat tip. Anyway, let's try to desolder something that's on a ground plane. This will have been done with silver solder. We've got it set to 330, which should do this fairly rapidly. Let's see. Use the flat tip of the iron there. Okay, not getting a good result on the initial flow here. Let's kick it up to 380. Oh. Still not getting a really great result here. Alright, so just a dry solder, nothing too inspiring there. So let's dab some flux on there, and we'll wet the tip of the iron with some lead-based solder, juicy lead-based solder. And let's see if we can, oh, there we go. Okay. So it was probably a little much for me to expect the iron to be able to dry solder on a ground plane there, but it was worth a try. Yeah, and on something that's not a ground plane dry soldering, it works fine. So that is a good result. All right, so let's go ahead and do a little desoldering. Again, we'll do my standard technique for desoldering, which is to flow a bunch of extra juicy lead-based solder. And where's my vacuum desoldering tool? There we go. Making a bunch of noise here in the background. Good result there. And then we'll wet the wick with a little bit of flux, and we'll wet the board with a little bit of flux. Oh, there actually is a plated through hole there. Let's try to clean that hole up. This seems counterintuitive, I know, putting solder onto the plated through hole, but you'll find that adding solder will quite often help in the removal of solder from a plated through hole. Let's try to go at it from this side. Dab a little more solder, or that's not solder, that's flux. Having a bit of trouble getting the solder out of that through hole, but it's generally fairly difficult to get solder out of a plated through hole anyway. Yeah, we'd have to try some different techniques with that, but honestly, for 20 bucks with a quick temperature change there, power button. It didn't come with an adapter. It actually came with the proper flex for the US. I'd say that's a good result. I'm pretty well pleased for the money I spent on it. So thanks so much for joining me on this somewhat rambling review. If you liked, click that like button below. Also, please consider subscribing if you haven't already. There's also a bell icon that will notify you if you click that when I release a new video, I'll put a video that YouTube thinks you'll find interesting there. The product reviews playlist will show up there if you want to see my other product reviews where I ramble just as much as I did in this one. And we have the Patreon right here if you'd like to support the channel with a couple of bucks a month to help me buy more things to review and build. So thanks so much for watching, and we'll see you next time. Bye-bye.